So we're going to finish up 9.6 and then we'll do 9.7. Okay, so in 9.6, the ending of it that we were finishing up was solving logarithmic equations. Okay, equations that have logs in them. So let's look at number 15 is where we're starting. Log base 3 of x plus 1 minus log base 3 of x equals 3. Okay, now the first thing we need to do, since we have two log base 3s on the left side of that equal sign, I want to rewrite that as a single logarithm using those logarithmic properties. Since these are subtracted, I can turn this into a quotient of those logs. So I'm going to have log base 3 of x plus 1 over x equals 3. So now, since we just have one log, that's when you're going to turn your logarithmic equation into an exponential equation, right? So I'm going to have, this is the base of my exponent raised to that power. So I have 3 to the third power is equal to what's in this position, which is x plus 1 over x. 3 to the third gives me 27 equals x plus 1 over x, which this creates another one of those cross multiply situations, right? Because I can think of this as 27 over 1. So if you have one fraction equal to one fraction, you can use cross multiplication to rewrite it without fractions. And cross multiplication says when you multiply this diagonal, so 27 times x gives me 27x. It's going to be equal to multiplying the other diagonal. So if I have x plus 1 times just 1, I still have x plus 1. And then isolate that x, get that x by itself. So subtract x from both sides. So now I have 26x equals 1. And divide by 26. So you're just left with x equals 1 over 26. All right. Number 16. ln of x plus ln of x minus 1 equals ln of 2. So again, if you have multiple logs on one side, use the rule where you can rewrite that as a single log. So this time, since it's added, I'm going to turn that into the product of the two ln's. So I'm going to have ln of x times x minus 1 equals ln of 2. Now, we did one like this in the last section, or in the last lesson. If you do have logs or ln's on both sides still, then you can just divide them off, right? If you can do whatever you want, as long as you do it to both sides. So I'm just going to divide off those ln's to cancel them. So let's see, if I distribute this x, that'll give me x squared minus 1x equals 2. So this is telling me now that it's quad, which means I need to get all the terms over here with that. So I'm going to subtract the 2 from both sides. So now I'll have x squared minus 1x minus 2, which you can take that straight to quad and type in your a, b, and c. If you didn't have your quad with you, then you would use factoring. So x and x for x squared Factors of -2 that add to -1, or a -2 and a +1. But then when you set those equal to 0 to solve them, this one you would add the 2 to both sides. So x equals 2. Here, subtract 1 from both sides. So x equals -1, but you have to be careful about negative answers because I can't put a -1 in for this x and then L in it. It would give me not a real number. So the only true solution is that 2. And 17. Log base 3 of x plus 4 plus log base 3 x minus 4 equals 2. So same thing on the left. I'm going to rewrite that as a single logarithm. Since it's adding, I'm going to rewrite it as the product of those. So log base 3 of x plus 4 x minus 4 equals 2. Now remember, at this point on the last one, I still have logs on both sides, so I divided them off. But if you just have one log left, that's when you turn it into the exponential equation. Okay, one log left always means turn it into exponential. So I have 3 squared equals x plus 4, x minus 4. Three squared gives me 9 equals, if I FOIL this, x times x gives me x squared. My outer is -4x and my inner is +4x. And then my last is -16. When I combine these x's in the middle, they cancel. So now I have x squared minus 16, which again makes it quad, which means I need to move the 9 over here. So minus 9 from both sides. So now I have 0 equals x squared minus 25. So again, you can take that to quad and plug it in. Just be careful. What's missing? The x, which means the b is 0, right? Your a is 1 and your c is -25, which would give you 5. And -5, which again, the -5 turns this into a negative, so you can't have that. So +5 is the only answer. Okay, now we're going to do 9.7. So I'm going to give you a formula. 9.7 is on what's called exponential growth or exponential decay. All right, this P of t, that's going to be your ending amount. Okay, and a lot of times that's what's going to be what you're looking for. This P with this little zero down here, that's the amount that you're going to start with. And when I say amount, we're talking about anything. We're going to be talking about money, population, it's going to just be what amount did you start with whatever you're talking about. Okay, then you have this E that's always there. That's part of the formula. That's the E that we've used before. Then K is your rate, and we always want it in decimal form. And then T is the amount of time in years. All right, number 1 says, in 2012, the population of a city was 5.43 million, and the exponential growth rate was 2.11% per year. So I know 2 things. I know the beginning amount of the population, and I know the rate in which the population was increasing. So it wants us to write what that looks like in this formula. So again, the beginning amount and the rate is what I know. What the beginning amount was 5.43 million. And the rate was 2.11%. Now remember, you need to write that in decimal form. So you're going to move the decimal 2 places to the left. So in decimal form, that'll be 0.0211. So let's rewrite this, filling in what we know. Okay, that's going to be the answer to the first part of the question. P of T equals, the beginning amount is 5.43. E, then your exponent is going to be the rate, which is 0.0211 T. So now on this next part, it's asking us, what is the population of the city in 2018? So this was in 2012, which means I know what the T, I can fill in for the T now, because if I'm talking about 2018, how many years has it been since the population in this picture started? 6 years, from 2012 to 2018. So I'm finding P of 6, which means I'm just replacing the T, which is the years, because it's been 6 years. So I have 5.43 E to the 0.0211 times 6. So again, just putting that in my calculator now, 5.43. Now remember where that E is. It's the LN button, but above it. So you'll just have to push second LN to get the E, and it automatically puts you up in the exponent for you. So up in my exponent, I put 0.0211 times 6, just like it is. So just put parentheses around the 6 and hit enter. And it says to round to 1 decimal place as needed. So I have 6.1. After the 1 is a 6. So I just round that up to 6.2. So what that's saying is the population will be 6.2 million after 6 years if it's growing at 2.11%. Now, the next part says the population of the city will be 8 million in about blank years. So now That's the end amount, the 8 million. So the beginning amount is still 5.43 million. It wants to know how many years, so I'm looking for T. How many years will it take it to get to 8 million? So T is what I don't know in this problem. So look what happens here. So I know the end amount, which comes on the left. The beginning amount is still 5.43. The K, or E to the K hadn't changed. T is what I'm looking for. I'm looking for how long did it take to get to 8 million? This T is what I'm solving for. It is up in the exponent, which means we are going to use those log properties to bring it down. But before I do that, I can first off start off by getting rid of that 5.43, right? Because my goal is to get that T alone. So if I divide those sides by 5.43, that'll cancel that. All I have left over here is E to the 0.0211 T. On the left, I'm not even going to do this yet. I'm going to do this all at once at the end. Now, I'm going to use that property that said that's going to help me bring the T out of the exponent. Since I'm dealing with E's, instead of logging both sides, I'm going to ln both sides. So again, that lets me bring the exponent down now. So I have 0.0211 T times ln of E. But remember, what is this equal to? It's 1. So this right here, you kind of like don't even need to see it. So what do I need to do to get this T by itself now? Divide by 0.0211. So now my T is alone. And then this is calculator work. In this, I'm going to do ln 8 divided by 5.43, close it, go ahead and hit enter. So I'm going to go ahead and hit enter after I figure that out. And then just hit divided by again. 0.0211. And round it to the nearest 1 decimal place. So I have 18.36. I'm going 1 decimal place. That's just going to round that up to 18.4. So it'll take 18.4 years after 2012 for the population to get to 8 million. The last part of this problem says what's the doubling time? Or in other words, how long is it going to take the population to double if it's growing at 2.11%? Doubling time, the formula for doubling time is always the same. You're just going to have ln of 2 over your rate in decimal form. And then push that in your calculator. So ln 2, close the parentheses, divide it by 0.0211, round that to the nearest decimal. So it wants me to go 1 decimal place again to the 5, rounds the 8 up to 32.9. Right, number 2 is a doubling time problem. It's going to give me a chart. With country A and country B. And then it says the growth rate, which is the K, for country A is 2.1% per year, and it wants to know the doubling time. So remember, what's doubling time? It's always the same thing. ln of 2, ln of 2 over K, over the rate. So this one I would just have, turn this into decimal. So this will be 0.021. So we're going to round this one to the nearest whole number. So ln of 2, close it, divided by 0.021. If I'm rounding this to the nearest whole number, since it's 33.0, so that nearest whole number would be 33. So it would take 33 years for the population to double if it's growing at 2.1%. Country B tells us that it takes 28 years to double the population. What is the rate? So this K is going to be ln 2 again, but over the doubling time. That'll tell you how fast the population is growing. So ln of 2, close it, divide it by 28. And we're going to round this to the nearest 10th. So I got 0.024. So if I'm now I got to turn it to a decimal. So not a decimal, I do the decimal, turn it to a percent. So it's 2.47%, which rounds to 2.5%. So if it took 28 years for the population to double, that means it was growing at 2.5%. All right, number 3, talking about investing money. Now, in the previous section where we worked some of these problems, it was the formula was different because of how many times the money was compounded, or the investment was compounded. If it was compounded quarterly, we would replace the n in that formula with a 4, right? This is talking about compounding continuously, okay? If it's compounded continuously, this is the formula that you use, okay, instead of the other one. This says, suppose that you invested $11,674. That's going to be your beginning amount. At an interest rate of 5.8% per year. The first thing it wants me to do is come up with the Pmt formula, just like we did in number 1. I need this to be a decimal. So it'll be 0.058 in the K spot. So P of T is equal to your beginning amount, which is 11,674, E. Then your exponent is the rate times T. So it'll be 0.058 T. Then the next 4 parts of this are just saying how much do you have after a certain amount of years. So I'm just going to do 2 of them instead of all 4 of them. I'll do the first one. The balance after 1 year. So what are you finding? You're replacing the t, which is the year, with 1. So 11,674 e to the 0.058 times 1. Rounding it to 2 decimal places. So 11,674 e, and your exponent 0.058. Open parentheses 1, close. Then hit enter. So let's see, 2 decimal places. So after the 11 is a 2, which means I don't need to round up the 11 cents. So I would have $12,371.11 after 1 year. Okay, then it wants you to do 2 years, 5 years, 10 years. So all you're doing every time is just replacing this, right? So if I'm going to do the last one for 10 years, I'm just replacing the t in the formula with a 10. So 11,674 e 0.058, open parentheses 10, close. Enter, again, rounding to 2 decimals. So after that 21 cents is a 2, so I don't need to round up to 21 cents. So after 10 years, I'll have $20,850.21. Then the last part of this says the doubling time. How long is it going to take it to double? Doubling time is ln of 2 over your k, which is your rate, which is 0.058. We're rounding this to 1 decimal, so ln of 2, close that parenthesis, divide it by 0.058. So this would give me, wants me to round it 1 decimal. But since this is a 5, what's happening to this? It rounds to 10, which rounds this to what? 12. Or 12.0. So that is the model that we use for when things are growing at a when we know the rate of when things are growing. Okay. What about if they are going down? Now, for some reason they don't use P's. I'm sure there's a reason. They use M's. The only thing that really changes about the formula is that needs to be negative now because we are declining instead of growing, which means your rate is going to be a negative number. All right, number 4 has this chart. the story is the data in the table shows that the percentage of adults in a country who are currently married is declining. Assuming that the percentage of adults who are married will continue to decrease according to the exponential decay model, complete parts A through C. Okay, so the first thing it wants me to do, it says, is find the K, which means I need to know everything else. So what does this stand for? The same thing it did in the last one. That's the end amount. So what was the percentage married at the very end of the story? 41.4. What was the beginning percentage married? 66.7. E to the negative, looking for K, so I don't know K. T, I do know how many years it took because I knew this one was in 1960 and this one's in 2012. So how long did it take to go from 66.7 to 41.4? 52 years. So I'm solving for K. So let's see, the first thing, which means I'm eventually going to have to ln both sides to get it out of the exponent. But before I do that, I'm going to get rid of the 66.7. So now I have E. Now instead of writing this negative K times 52, I'm just going to write it as negative 52K. It doesn't really matter. Over here, I've got 41.4 over 66.7. Now I need to get the K out of the exponent, which means I need to ln both sides. So that brings the whole exponent down. So now I have negative 52K times ln of E, but remember ln of E is just 1. So what do I need to do to get this K by itself? Divide it by that negative 52. So now my K is by itself. So once I do this, I'll know what the K is. So in your calculator, let's see, I'll have ln of 41.4. Bless you. Divided by 66.7. Now, I'm going to close that and go ahead and hit enter. After I hit enter, then I'm going to do the divided by negative 52. And I'm rounding to 4 decimal places. So I've got 0.00917. Seven's in the 5th spot, and since it's above 5, or 5 or above, it's going to round that to 0.0092. So now that we know what the K is, 0.0092, it wants me to write the formula that I would be able to use if I wanted to go further in this chart, which means I need to know 2 things. I need to know the beginning amount and the K. The T is what's going to be unknown that I'll be able to fill in to go further. So let's see, I'm finding M of T. So my beginning amount doesn't ever change. It's 66.7. E to the negative, right? You want to put a negative in front of it since you're actually going down. 0.0092 T. Because now it wants to know what the percentage of adults is that are married in 2015. So how many years after 2015, or excuse me, after 1960 is 2015? 55 years. So I'm finding M of 55. So I have 66.7 E to the negative 0.0092 times 55. So again, just type that in your calculator, 66.7 E, and remember, E is second ln, and then in your exponent, negative 0.0092 with the 55 in parentheses. And hit enter. Rounding to 1 decimal place. So since it's 40.21, that just means in 2015, it'll be 40.2. For 2018, what is this going to change to? It'll just be 58. So putting that in my calculator, 66.7 E to the negative 0.0092 times 58. And rounding that to 1 decimal, so 39.11. Which means I don't need to round up. So in 2018, 39.1%. So the last part says, at this decay rate, in which year will the percent of adults who are married be 35%? So now what do I know? That number. So 35%, which is what? The end amount. What does it say I'm looking for? The years. So I'm looking for T. So I need to fill in everything but T. So I know the end amount now, which is always what's in this position, which is 35. The beginning amount is 66.7 E to the negative 0.0092 T. So again, anytime you're solving for a variable that's in the exponent, you are going to ln both sides at some point, but always get rid of what's here first. So divide by 66.7. So now I have E to the negative 0.0092 T equals 35 over 66.7. Now ln both sides. That'll bring down my exponent. So negative 0.0092 T times ln E. So for T to be by itself, I need to divide by negative 0.0092. So again, in your calculator, ln of 35 divided by 66.7, close it and go ahead and hit enter. And then divide that answer by negative 0.0092. Well, what are we doing here? Nearest whole number. So it's 70.0, which is 70. But this wants to know, at this decay rate, in which year will the percent of adults who are married be 35%? It's not year 70. What does this mean? That's 70 years after 1960. Which gives me 2030. So 2030, if it continues to decline at the same rate, is when the percent of adults married will be 35%. All right, number 5, the number of farms in a certain state has declined continually since 1950. In 1950, there were 85,641 farms. And in 1995, there were 21,717. Assuming that the farms decreased according to the exponential model, find the value of K. So let's see, do I know the end amount? The end amount is 21,717 equals the beginning amount is 85,641 e to the negative, I don't know K, but I do know T because I know how long it took to get from the beginning to the end, which is 45 years. So now solving this for K, just like we've been doing. So divide by 85,641. So now I have E to the negative 45K equals this. Now ln both sides so that you can bring down the exponent, the exponent. So negative 45K equals this side and then divide by negative 45. So my K, let's see, ln 21,717 divided by 85,641, close it, enter, and then divide that by negative 45. And then enter, and we're rounding. It looks like since it's multiple choice, they all went to 3 places. So 0.030. Okay, now here's where I'm going to kind of disagree with this. Now, I guess what they're saying, do you notice that all those are negative? So I guess that's what they're saying is that the K, when I plug it in to the formula, it's going to have a negative in front of it, right? Because it's declining. So you're looking at the one that has that as the K in the K position, which looks like A. Last one. All right, there are currently 68 million cars in a certain country. decreasing by 1.4% annually. How many years will it take for this country to have 38 million cars? So how many years means I'm looking for T. I know the beginning amount, the end amount, and the K. End amount is 38 equals the beginning amount is 68. E, I need to rewrite this as a decimal. So negative 0.014 T, and we're solving for T. Divide by 68. So now I have e to the negative 0.014 T equals 38 over 68. ln both sides. Which brings down your exponent. So negative 0.014 T times ln of e. So my last step will be to divide both sides by negative 0.014 to find my t. So ln 38 over 68, close it, enter. Now divide that by negative 0.014, rounding it to the nearest year, the nearest whole number. So 41.5 will round to 42 years. So it'll take 42 years for the cars to go from 68 million to 38 million. All right, so that is